Afternoon, evening, whatever is where you are after yesterday's epic failure. We're back, hoping to do a bit better this time. You may notice I've got some more space here. That's because I'm going to be joined by my friend Christopher DeBella, who is staying with us from the States for a bit. He works on C++ stuff at Google, so he can help hopefully catch my silly mistakes. Hey Aaron, how's it going? So he's going to be joining me shortly. He just arrived this morning, so is very jet lagged. But Milkshake is here as well, my cat. Anyway, yesterday's puzzle didn't go so great. We'll hopefully do today's puzzle, and if we have time, we'll go back and try and address the the problems which we had yesterday. So day 12 is going to be a hill climbing algorithm. You can see I'm going slowly because I want to wait until Chris is here until I read out the puzzle. But basically, for people who didn't come yesterday, I spent a bunch of time just screwing around with parsing because I had some issues with my string splitting function, and it was like half an hour in and I'd barely got started. Just one of those days where you do some programming and nothing goes right. So we hopefully will not have that today. Hey, come in.
Okay.
Oh, you changed your username. Hey, Emily, how's it going? And Chris is here.
Hello.
I can... There, that should kind of work.
Our face is good.
That'll do. Cool, do you want to say hi to everyone, introduce yourself?
Hi folks, I'm Christopher. I am a friend of Sai's. We used to work together, and I work on the ChromeOS toolchain at Google, predominantly making things like Clang more user-friendly.
Yeah, and you're working on... are you still working on the diagnostic stuff for Clang at the moment?
That is the main thing that I'm looking at. Basically makes... The idea is to make diagnostics be much nicer than they currently are. Diagnostics are errors, warnings, that sort of stuff, and there's a lot of room for improvement. Hoping to change that.
Yeah.
No promises though.
I just added some extra space around your face so it doesn't get cut off in the stream.
Oh, nice.
Cool. So we haven't read the puzzle for today. So for context, yesterday I completely bombed on stream, which was not what you want to do, but hopefully we will not do that today. So, hill climbing algorithm. You try contacting the elves using your handheld device, but the river you're following must be too low to get a decent signal. You ask the device for a height map, another height map one, of the surrounding area, which is your puzzle input. The height map shows the local area from above broken into a grid. The elevation of each square of the grid is given by a single lowercase letter, where A is lowest, B is next lowest, and so on up until Z. Also included on the height map are marks for a current position, which is S, and the location which should get the best signal, which is E. Your current position has elevation A, and the location that should get the best signal has elevation E. Which is
Z.
Sorry, Z, yes. Which is the highest. So we're climbing up. You'd like to reach E, but to save energy, you should do it in as few steps as possible. It's a pathfinding exercise. During each step, you can move exactly one square up, down, left, or right to avoid needing to get out your climbing gear. The elevation of the destination square can be at most one higher than the elevation of our current square. That is, if our current elevation is M, you can step to elevation N, but not to O. This also means that the elevation of the destination square can be much lower than the elevation of your current square. Okay, so you can go up one step, but you can go down as many steps as you want. So for example, we start with S, and our goal is near the middle here. You could start by moving down or right, but eventually you'll need to head towards E at the bottom. From there you can spiral around the goal, and options kind of look like this. Location that you should get the best signal is still E and dot marks unvisited squares. This path reaches the goal in 31 steps, the fewest possible. What is the fewest steps required to move from your current position to the location that should get the best signal? Okay. So, what's this is an algorithm, like a well-known algorithm. This is depth first search. The grid is basically a graph, and we want to search the graph depth first until we find E, because that will give us the smallest number of steps. So I haven't implemented hi Milkshake. I haven't implemented depth first search probably since last year's Advent of Code, but it's like it's a queue, right?
Yes.
I think the algorithm is like you
stack. Depth first is good, very good for trees, right?
Depth first you can just do recursively. Breadth first is better with a queue, because I think the algorithm is you start off with your root node, you add all of the children to a queue.
Yep.
Then for each element in the queue, if you haven't already visited that element, then you mark it as visited, and then you add all of its children to the queue, and then you just iterate. I think that's the algorithm.
Sorry, are we doing depth first?
We're doing breadth. Breadth first.
Okay.
Yeah. So we're going to parse this into a vector of strings. So we can use, I've got this handy TL getLines thing, which will give us our lines as a range, and then we can convert this to a vector using TL2.
I didn't even plan 2. Nice.
Oops. To vector. Okay, so now we should have a vector of strings which we can just index handily. Alright, we want to find our starting position. Alright, let's make a little coordinate type, because we're going to be using this. Let's do get start position for lines. We're just going to turn a coordinate. Okay, and we're just going to find S. Oops. Just nested loop, and if lines ij equals S, then return ji.
So you've got a multi-dimensional thing here, but our lines on 22 is only single-dimensional, right?
Our lines are stood strings.
Oh, right, of course.
Should we also get the... While we're doing this, we can get the end position as well. Get start and pause. I. Otherwise, if it's end, then end equals ji, and then we could short circuit and work out like when we've got both start and end, but for now we can just do return pair start end. All right, hacky, but it'll be fine. Can use structured bindings. Okay, so now we've got the start and end position. Now we want a queue. And basically we're going to loop over the 4 neighbors of the coordinate we're looking at. If they are valid, i.e. within the grid, and either lower down or at most 1 position higher, then that's going to be valid, and we can add that to the queue for further processing. So we and also we want to make sure that if we're looking at the end coordinate, then we're finished. Okay, so maybe we can start off with a queue of coordinates, which is going to be acute. Thanks to the follow Yogurt Queen, great name. Okay, so we're going to start with the queue, which will begin initialized to start. And then while q dot top is not end. Is that right? We're just gonna keep on iterating until we find until we're looking at the end coordinate.
Should also probably have one about not empty as well.
If we get empty, we've done something wrong, right?
I think so.
We can see, like, if it turns out that because if we do q.top, does that throw if the queue is
I honestly
empty?
can't remember what it does, but I'm sure that ASAM will tell us. Sorry, address sanitizer should use the full name.
Anyway, but we can stick with this for now. And so while we're not at the end, for each of the 4 neighbors, we're gonna filter on whether they're valid and then add them to the queue.
Should we be weighting them? Because we can go down many spaces, but then we've got to climb our way back up, and we want to do that as little as possible too.
I think because we're adding everything to the back of the queue, that'll deal with it for us.
Okay.
We do need to keep track of the number of steps that we have walked, though. And we also do need to keep a track of the set of coordinates which we have visited, which will also begin. But we'll add start to it. So anyway, the first thing that we do is add visited. I need to actually include set. Visited.insert q.top. Okay, and then we're in kind of pseudocode. We're going to do for each child of or each neighbor of q.top. Then we're going to do q dot what was it? Q.push, Q.insert,
Push, I think.
Q.push, our neighbor. I'll fix this up into actual code like once I've got the algorithm down. We're gonna do it if it's valid. Then we're gonna push it to our queue, and then we're going to we need to remove the, let's say top here equals q dot. I have to look up the API for std_q.
It's front is the thing to get the thing from a queue, and then pop is, I think it's pop, is to get the
Front and top, right?
Yeah.
Front and pop.
front and pop. Yeah, that sounds right.
Yeah, you're right.
Tops for stack.
Yes.
Why they're not consistent? I don't know.
Equals q dot front, q dot pop. And okay, so for each neighbor of a front element, if the neighbor is valid, we're going to push that to the queue, and we've already dealt with visited. We do need to keep track of how many steps we have gone for each thing. So maybe our queue is a pair of coordinates and the number of steps.
From memory, Inventor Code does like to have a lot of input in its things. Should we go for a large integer or just a regular int?
How big is this?
That's
It's not too big.
This is gonna be famous last words.
It's not going to overflow in anyway, I don't think. So we're going to start off with our queue as start and 0. And, instead of making this a pair, I'll make this a proper type. I'll just call this entry. Entry is going to have a coordinate called C, and it's going to have n steps. Okay, so then when we get our front, we're going to do front.c. And then when we, let's say, front chord, front steps. Then when we push our neighbor to the queue, we're going to push entry and then front steps +1. Legit?
Mm-hmm.
Okay, so now we have to actually get all of our neighbors, which will be something like for neighbor and let's just call get neighbors of front chord. So now we need to implement get neighbors and valid neighbor and valid. Valid is going to take a bool, which return a bool, going to take a coordinate C. We also need to take. We also need to know the bounds. All right, because if we don't want to access something out of bounds. And we also want to know. We also need to capture the map. So we could make this a lambda. Valid. It's going to take a coordinate. And so it's going to be valid if coordinate dot x is greater than 0 and coordinate dot x is less than our lines 0 dot size, and c dot y is greater than 0 and c dot y is less than lines dot size. And thanks to follow Kutsup. And what we're moving from is what we're moving to is at most one higher than what we're moving from, so we really need a coordinate from and a coordinate to. So is valid front chord to neighbor. Our lines from dot y from dot x actually our lines to dot y to dot x minus our lines from dot y from dot x is less than 2. Is that correct?
Y less than 2.
It has to be in most 1.
Oh, right, yes.
Or our or we're looking at E as our 2, which is going to be let's say auto to the character we're moving to is
oh, you're allowed to climb extra steps if it's E.
No, but
Okay.
but we need to fix up E. So we're gonna say to character is if our to character is E, then Z otherwise to character, just to make sure that we handle that situation. And additionally, we need to deal with the case where we're at the start position, in which case we're pretending that we are at A. Okay. How's that look?
Yeah, it looks pretty good.
So that will tell us if our a move from our front coordinate to a neighbor is valid, and then we just need to get our neighbor's yeah, we can just get neighbors for chord. You can't return a initializer list, can you?
I think you can.
I think it immediately dangles, doesn't it? It's like
it's a view to an array.
Std initialize, yeah. We could do this without allocating, but just for.
Could use std array, but if we've already got vector included, there's no point changing.
No, we don't even have vector included at the moment, and I think we're gonna need it because we did a.
Yeah, you got 2 vector.
Yeah.
We can use ctat here as well to not have to specify the size.
Yeah. So we're gonna return an array of c dot x c dot y. So it's +1, -1. There are more elegant ways to do this, but this will work. I think we probably need to say that these are all coordinates, right?
Yeah, I realized that after you put the braces in, I was like,
yeah,
we're gonna have to specify something somewhere.
Okay, so this should get all our neighbors, and then if they're valid, then we push them all to our queue, and then at the end, we're gonna do cout queue.front dot end steps.
Why are we writing that to the character output?
Just because that will give us the answer in our terminal.
Oh, that's not in the loop. Okay. Sorry, I thought that was still in the loop. There's one thing we haven't done yet, though, and that is that we haven't used visited. We should probably exit early. Not exit, continue, or like go to the next bit of the loop if we we've already visited.
Yes. At this point, we only add to the queue if neighbor has not been visited.
Why is that?
Because if the neighbor has already been visited, right, then we've already gone through this whole process and pushed its neighbors to the queue.
Okay. Do we need visited in that case, or is that something that?
Yes, we do.
Okay.
We can do it. We can do it in valid. Like we can say. And not
I get what you're saying,
visited dot contains 2. Okay. Add some parentheses here. Okay. Can't convert from initializer list to std queue. Here.
Alright, queue doesn't. We're gonna have to push that.
Does queue not have a initializer like that?
I think it may have been proposed for C++23, but I'm not 100% sure.
Like that?
Yeah.
Okay, that's better. Oh, whoops. Okay. Queued up front is an entry. front dot C.
Still won't work because we haven't provided a comparison operator.
Oh, yeah. Mm,
Do we want a spaceship or do we just want equality?
oh, you can do that now, right?
Yeah. The reason I'm suggesting that is because otherwise we'd have to say auto for the operator's return type and include compare, which is just extra steps.
Oh. It's a local class.
Oh, forgot about that.
Okay. Chord and chord. Oh, did I implemented it for the wrong
I reckon we should keep it for entry.
thing.
Hold on, we need to change parameter types too.
Yeah. Okay, we're doing that here as well. Oops. And whoa.
Okay, looks like we need to implement the spaceship operator because this is from set, I think.
Oh, from set. Yeah, you're right. Because we have a set of coordinates, which means that we need to have less than defined.
And we'll need, no, everything includes compare transitively, so we don't need to include anything extra. I keep forgetting about that rule.
Oh, this is from yesterday. I don't care about yesterday. Yesterday was bad. Okay. Well, we ran. I didn't copy anything into the input, so we're not going to get anything interesting. Let's see how we go. Debug assertion failed. That's no fun. String subset out of range. Oh, okay. We need to check our bounds before we do all of that nonsense. If we're not in bounds, then return false. And then do that. And then check that our move is valid and that we haven't already looked at our at that specific coordinate. Debug assertion failed again. What this time? Front colon empty deck. Maybe you were wrong, right about So Q. Yeah, let's stick a breakpoint on here. Just make sure. Okay, so we start off with Q is our start position, which is 5, 2.
5-2. Should
That's not right. That looks like E. Have I flipped something here? Get start and end.
So you've got I and J in alphabetical order on the left side, but then when you're doing the assignment,
Oh no, that shouldn't make. Yeah. Axis order. I still think there's separate issue potentially. Why does it require less than and not just equals? Because we have a std set of coordinates, and std set relies on the less than operator. Okay. So our queue starts off at 0, 0, and then we pop from the queue. We say that we visited our front coordinate. For each of our neighbors, so our first neighbor is 1, 0. Will that be valid? That will be moving from A to A, so that should be fine. So we just step into this. Is it in bounds? It says not in bounds. Well, that's wrong. Why is it not in bounds? Greater than or equal to 0. 0 is valid. Yes. Okay. Let's try that again. So we check if our first neighbor is valid. Are we in bounds? True. Yes, we are in bounds. Our to character is A. Our from character is S, and we fix that up to be A. And then we return this, which should return true. Return true. Sweet. Push our that neighbor and front steps +1 into the queue. Alright, let's just continue. Debug assertion failed. Front call an empty deck again. Okay. So where are we at this stage? We visited 40 places and haven't found... Oh, we don't actually... Because the idea is we get to a point where we push, where one of the neighbors is our end coordinate. Our end coordinate is 2, 5. 2, 5 is not there. Is this again axis order issue? What's the size of this thing? 5 by 5 by 8. So what is the axis order here? This is looking at 7, 4, which is here.
Yep.
So it should be 5, 5, 2, and it's 2, 5. Yeah, we've got an axis order issue.
I didn't even see that one. Where is it?
I think it's where is it? I is Y and is that it?
Didn't we just come from that, or did we have another?
We had another issue. I think.
Okay.
31. There we go.
Nice.
All right, let's give this a try. And taking a while to run.
But we're doing it in debug mode too.
Still shouldn't take this long, right?
Do you want to pause it and see where we're at in the
queue length is way too big to reasonably be correct. Like, like what is visited at this stage? 587. Like, seems like we've visited like almost every.
How many nodes are in the text?
It's so right now we're like at the end of the queue, still 24 steps in. Are we adding too many things to our queue? Anyone see what our mistake is here? Because we're obviously like doing some work which we're not backing out early enough from something. Like, where is our E is over here.
Do we have, oh.
No, my monitor just cuts out sometimes.
Okay. Can you go back to the input, please?
End is 13920. We haven't even got close.
Okay, where is our S?
Our S is at 020.
Okay. Can we just confirm that S is in the string?
Yeah, it's right here. It's on the same line as E.
Oh, 020 is going down the column, not across. That's why I couldn't find it. Sorry.
What could the problem be?
So when I have written breadth first searches, I've typically put the visited check as close to the top as possible after popping, because I found that if I don't do that, it'll I'll sometimes run into a problem where I'll infinitely run through things because I may be doing it a bit too late.
We do want to label W as explored not when we visit it for the first time, but when we enqueue it.
Yes, that makes sense.
So this goes here, and it's neighbor, and we initialize visited with start. And that should stop us from getting to that situation where our queue is just massive. Oh, there we go, that's much better. 481. Sweet. Part 2. As you walk up the hill, you suspect the owls will want to turn this into a hiking trail. The beginning isn't very scenic though. Perhaps you can find a better starting point. To maximize exercise while hiking, the trail should start as low as possible, elevation A. The goal is still the square marked E. However, the trail should still be direct, taking the fewest steps to reach its goal. So you'll need to find the shortest path from any square at elevation A to the square marked E. Okay. Now there are 6 choices for the starting position. If you start at the bottom left square, you can reach the goal most quickly. This is like a dynamic programming problem, right? You, or is it we go backwards? Do we do a backwards depth and breadth first search for any A from E? Is that equivalent?
Dynamic programming is not my strength. It was the one section in the algorithms class I took that I dreaded the most.
I think like if we do a backwards breadth first search, we start at E and we find the first.
Yeah.
We just keep on walking until we find any A, and then we return the number of steps.
That works perfectly.
So part 2. Let's just copy paste all of this. So part 2 is gonna, instead of starting at start, we're gonna start at end. And instead of checking if we're at end, we're gonna check if our front coordinate is an A. Whoops. Queued up front C dot X dot Y. Don't want to make that mistake again. Dot X is not equal to A. Is that all we need?
I think so.
We could definitely refactor a lot of this. It also says 481. That's just because I ran part 1 again.
Should we give it the sample input just to...
Let's see if we get a answer out. Debug assertion failed.
Well, that's an answer.
Front called on an empty deck. Where visited is 1, and let's just quickly make sure that we're not doing something completely wrong. So our front coordinate should be end, yes. And then
we may have to change valid, because remember looking at something valid going forward, now we want to be heading backwards. But it looks right.
No, you're right. We want to make sure that 2 char minus from char minus 2 char is yeah, because we're now going downhill instead of although no, because we can, I don't know. Yeah, I was thinking like we can move downhill, but we're doing it backwards, so it's fine. 480. That sounds unlikely. Okay.
Oh.
Whatever. Nice. I'll take it. It's not the prettiest code ever, but it's better than yesterday. See, I'm happy with that. Thanks everyone for joining in. We don't have enough time to go back and do day 11, and I have no desire to. So I'm gonna end it there for today, and see you all tomorrow. Bye.